teachers. So I'm your scientist for today, and my name is Precious Janine C. Santiago, and I'm grade for the St. Edith Stein. So for today's experiment, we will be doing the walking water. So let's get started. So our materials for this experiment are 7 glasses. Make sure they are fully clear so you can see the experiment better. You can do for food coloring. You need a funnel. You need tissue or paper towels, and you need water. So let's get started. So what you're going to do is we are going to fill up some of these, but it's in the pattern. It's like you're gonna put water here, and now you're not gonna put some water. So let's get poured. So you need to make it halfway only. Maybe like that. Okay? No, okay. I'll put it a little bit. Yep. Yep, like so. Now this. Yep. And this here. The last batch. So you can always measure it if you feel like it's very full or not that full. So what you're going to do is we're going to put the food coloring. So we're going to do this one first. You can only put a little like that. And then this. Okay. I'm going to put this one here. Oops. Now this. Now we are going to mix it up. Okay, so we mix this up. You need to mix it up real good so the colors will pop eventually. So what we're going to do is you need tissue and you need to fold it like this. It imitates as a straw. So what you're going to do is you need to fold it like this, that. Then you need to do the folded part like this. Now we're going to put this here, to the empty glass, and to here. Okay, like so. Now we're going to do it all over again. So as you can see, the water is already walking towards here. I don't think you can see it very well, but if there's a close-up, you can. Oops. Ooh, the yellows. Look at that. They're already walking together. Okay, I'm just going to put this here. I'm going to put the yellow. As you can see, it's already absorbing. Let us not stick these together. Okay, let's move this a little. That. Ooh, look at these. Okay, now we're going to put this in here. It's already looking full. Okay. Okay, put it here. And our last one here. Perfect. And after that, it should look like this. As you can see, the yellow is already walking towards this glass, which is very cool. And we're going to wait for 2 hours, so let's go. It's called capillary action. It is important for the moving water and all of the things that are dissolved in it. Around it is defined as the movement of water within the spaces of porous materials due to the spaces of adenosine, chlorophyll, and the surface of tissue. And also, here is an example of capillary action. So let us example a tree, and there is water around the ground. It grabs it up and it goes on top of the tree. So I hope you like my experiment today. Precious Janine is out.
Pepper experiment.
Hello classmates and teachers. So I am your scientist for today and my name is Precious Janine C. Santiago. And today we're going to do the pepper experiment. So let's get started. So what you will need is a plate. It needs to hold just a little amount of water. You need some dishwashing soap, some pepper, and some water. So let's get on with the experiment. What you will do is you will put just a little amount of water, like that. Now we're going to open up our pepper. Don't need to put that. And now we're going to put the dishwashing soap in our hands. Okay, so we're going to dip our dishwashing soap in our fingers. Now we go. Look at that! Look at that! So the question is, why did the pepper float to the side when the dishwashing soap touches it? Well, as the soap moves the water and the surface tension changes, the pepper is longer floated on top, but the water molecules still want to keep its surface tension going. So they pull back away from the soap and carry the pepper along with them. So I hope you liked today's experiment. It is called the pepper experiment. And thank you for watching. Precious Janine, the scientist, is out.
Thank you for watching.